Okay, so today I will be solving a second order linear differential equation using the method of reduction of order. Okay, so today's equation is y double prime plus y equals cosecant of x. Okay, so since this is a non-homogeneous problem, okay, we will have to find a yp instead of the y1 or y2, depending on what we were given. Okay, so in order to find the yp, we first have to find our y sub c, which would be our complementary solution, right? Okay, and you would do that with a characteristic equation, and in this case that would be m squared plus 1 equals 0. Okay, and quickly solving it, we would get m equals plus or minus I. Okay, now we can write our fundamental solution set, okay, which would be cosine of x and sine of x. Okay, and now after that we are finally ready to write our y sub c. Okay, and that would be c sub 1 times cosine of x plus c sub 2. This was probably not a very good idea. Okay, let's just write it down right here. Okay, and this is our complementary solution, which will be used to construct our general solution. Okay? Okay, so now our next step would be to find y sub b, okay, using a v function, okay, times our y1, which in this, let's see, we had both cosine of x and sine of x, but in this case, it is wise to choose the sine of x function because our original function, our original equation has a cosecant, which is 1 over sine, right? So they are very closely related, so it will make our calculations way easier. Alright, so now quickly finding the derivatives of y sub p, we have actually, let's just do it directly. Okay, yeah, let's just do it directly. Okay, so this one would be v times sine of x. Okay, then we'd have y sub p equal v prime sine of x plus v cosine of x. And then our y double prime of p would be minus. Okay, and here we have a minus because the derivative of cosine is negative sine. Okay, so you'd have v times sine of x. Okay, so now with these values, specifically these two, okay, we can finally advance to finding our y sub b. Okay, so I took the liberty to just replace y sub p, to substitute y sub p and its derivatives into the equation. Okay, so we will get this, this equation. Okay, so here, if you notice, we can cancel these two out, so we would get, okay, let's rewrite the equation. Okay. Oops. Okay, now after that step, okay, and after that step, we could Okay, I think it's time for a z substitution, alright? So here, let's define our z to be v prime, and then our z prime to be v double prime. Okay, so rewriting this, we have, we have z prime sine of x plus 2z cosine of x equals cosecant of x. Okay, and we can further simplify this, okay, by dividing this whole equation by sine of x. Okay, so we would get z prime plus 2z cosine of x divided by sine of x, okay, and then we would have, okay, and then we would have cosecant squared of x, okay, which actually would be, I think it would be best to just write it as sine squared of x for now. Okay, so if you recognize this, this form, okay, that would be the form you would use for integrating factor, okay, because it's a first order linear differential equation. Okay, so I won't solve it in this video for the sake of time, okay, but see, I did solve it step by step here, okay. If you just on this first part, if you want to see the step-by-step procedure, you can pause the video and check this out, okay. But meanwhile, okay, I know that by solving it, my integrating factor, oops, okay, after solving it, I know that my integrating factor, okay, let's just call it IF, is sine squared of x, okay, and then when solving it, we would get, okay, once again, very briefly, if you want to see the whole procedure, you can just pause the video in the previous few seconds and see how it's solved step by step. Okay, so we can integrate both sides, right? Okay, to get rid of this, and you would have dx. Okay, so we would have z times sine squared of x equals x. Alright, when we can further simplify it, okay, by dividing both sides by sine squared of x, okay, and this function would be our v prime, okay, not quite what you're looking for, but we're just getting close to the final answer, okay. So in order to find v, we will have to find the integral of this function, okay. Okay, and you can even further simplify it, okay, by calling it the integral of x times cosecant squared of x, okay, and then let's not forget about the dx. Okay, once again, I will not solve this in the video because of my time limitations, but this second part would be the way to integrate it by using integration by parts. Okay, and after solving it, you will find that v equals the natural log of sine of x minus x times cotangent of x. Okay? Okay, now we can finally find our y sub p. Okay, does that show up? Yeah, it does. Okay, so I can find our y sub p, which would be our function v that we just found, times our y sub 1, which was sine of x, if you recall. Okay, and then we can multiply this, just write it out first, okay? X minus x cotangent of x, okay, times sine of x, okay, and now our yp equals cotangent of x, okay, sine of x times natural log of sine of x, okay, minus x times cosine of x. If you recall, cotangent is simply cosine of x over sine of x. So when you multiply by sine of x, you only get cosine of x. Okay, so that is our yp. And now, okay, we can find our general solution. Let's call that gs. Okay, and we'll find it is our y sub c plus our y sub b. Okay, let's erase it very quickly. Okay, and our final answer will be y equals, okay, our y sub c was c1 cosine of x plus c2 sine of x. Okay, and let's move on to the next line due to lack of space. Okay, and then we would have our y sub p sine of x times natural log of sine of x, okay, minus our x cosine of x. Okay, so this is our final solution. Okay, I hope this video was clarifying, and I will just, let's see, I'll just leave this here once again in case someone wants to see the detailed steps to solving through the integrating factor method and to do integration by parts as well. Okay,